Cool. Nice. Let me just put some music on. Is that good? Let's see. Yeah, I think that's good. Let's put it to 16. If the music is a little bit loud, just let me know, okay? Hello. It's Sunday for me, so happy Sunday. I hope you're having a great weekend. Ready for another week for work or school. Nice. Let me just do this. That's better. Cool. First of all, please go and check into the link. Give me a second. There you go. That should be mine. No, that's not it. Here. Cool. Okay, there's a link to check in. Nice. Cool. So, my name is Bullet. I am a robotics and telecommunications engineer. I am a streamer and also a pod leader. So, if you ever need any help with the MLH Fellowship, then I'll be happy to help. Just ping me on Discord. And yeah, I can help you with that. I've been a pod leader for 3 years, and recently this year I started to be a streamer. So, my first streams. So, having fun. Cool. So, I feel like the music's a little bit loud. Let me just set 18. I'll just put it at 15. There we go. Cool. So, let's go to interesting mode, okay? Let's see. Let me just do this. Cool. Double tap on the plus sign. Cool. Okay. So, introductions aside, this is a stream about intro to Linux. Okay, it means you don't need any prior knowledge of Linux. You don't need any prior knowledge of anything. This is basically an intro to, let's call it raw Linux. This is because I won't be showing Linux as the desktop, as the fun or the easy way to use it. I kind of want to show and go through the steps of how to, go into the file system with the terminal. What are the permissions? What is bash scripting? And lots of commands that we are going to play with. Okay, so cool. You can see my let's see. You can see my terminal. We probably there you go. Just zoom it in a little bit more. Is this good? I think it is. I hope it is. Okay, cool. So if you can see the commands correctly, just let me know. Okay. Cool. So I'm using my primary machine is on Windows. Okay, so you can see the PowerShell is there. I have a Raspberry Pi. Okay, this means I have a server that's always on, and I can SSH or connect to it whenever I want. Okay. The way to do it, and this is probably the first command that we are going to explore later, I just want you to see it, is SSH. Okay, so SSH bully is my username from a Raspberry. 192.168.113 is my IP. If you try it wherever you are, it won't work. Okay, and I'll explain all of this like in an hour. Okay, it'll work for me because it's in my internet. Okay, so cool. So this is basically Linux. Fairly simple. Like, if you want to see easy toggles, beautiful looking windows, like, you probably could use Linux like that, but if you're an engineer, if you're someone who wants to work with Linux professionally, text a little bit small. Okay, thank you for letting me know. Is that better? 1, 2, 3. Yeah, probably. Okay, cool. Is that better? Nice. Thank you, man. Cool. Okay, so this is like the raw Yeah, I think it's good. Um, just in case. This is the raw version of Linux. Okay, I'm using Raspbian, which is one of the distros for the Raspberry Pi. Okay, it works the same as Linux. It should be working as Ubuntu, as Debian, as other distros. Okay, cool. So first things first. What the heck is this? Like, whenever you connect to the server, you don't have a beautiful window. Where, how, what's happening? Okay, so first things first. Let's see where we are. Okay, so let's just try to traverse this together and see what happens when we type something. Okay, so let's do. Okay, hello's not found. Okay, so we understand that whenever we type into the terminal, has to be a command. Okay, there are lots of commands. Okay, the ones that I'm going to show are not all of them. We have lots and lots of commands, but we can see that we have to start every sentence with a command. Okay, so let's start by typing something that probably most of you will be thinking of. Help. So if you type help, you can see that we have a lot of things to read here. We have bg, bind, break, caller. We have compose, continue, coproc, declare, blah, blah, blah. You have lots of these commands. Okay, this is too overwhelming. So let's just do it on our own pace. Okay. First of all, how can I change? So where I'm at. So what am I looking at? If you type ls, ls stands for list. Okay, or listing the directory. It means show me everything that I've got here, not one level over, not one level down, just in this level. Okay, cool. Okay, and if you see I install PyDocker Minecraft, I'll explain that in a second. That's kind of embarrassing, but this is it. Okay, so ls lets me know that I can see different things. I can see bookshelf, which is a folder, desktop, which is a folder. You can see that folders are in blue. Okay, greens are everything that I can run. Okay, it ends with .sh. It means it's a shell script. Okay, so starting with that, this is fun and a little bit of embarrassing. I was trying to create a Minecraft server for me and my brother with mods. Horrible when you're doing it in a terminal. Okay, that's a bad idea, but ChatGPT said this works. So yeah, cool. This is what we have. Okay, now what the heck can we do? Cool. So ls tells us what we have in this directory. What about moving directory? So you can see that we have blues and greens. Again, blues are directories or folders. Okay, so we can move to folders, but we cannot move to files. Let's see that. Okay, if I do cd, which is change directory, okay, and I do get docker .sh, dropping Minecraft server tutorial dropping later. Yeah, probably. If it works, because I'm modding it, so if it works with mods, yeah. If it doesn't, we'll just forget that this ever happened. Okay, cool. If I do cd, which is change directory, get docker.sh, which is this one over here, get docker is not a directory, so it means I can move to folders, but not files. Okay, and let's see that in action. Cd desktop. Cool. So you see, it changed from this thingy, which I don't know how it's called in English, up to thingy desktop. Okay, it means wherever I'm at, I moved from this into this. Now let's see what we have inside. Again, install PyDocker Minecraft. I was playing with it. I didn't break my Raspberry Pi just because it's resilient, but yeah, I was playing with it a lot. I have something called Minecraft World, which is where the mods are in, MLH portfolio, the runner, and shell scripts. Okay, again, greens are files that I can execute. Blues are folders. Okay, as simple as that. So, this is unrelated, but do you know what happened with cloud storage and databases 101? MLH Twitch never went online for it. I'm not sure. Double check Discord and check if it's Joss's or Jocelyn's stream. I think she just rescheduled it. I'm not sure. Yay! Also, Linux. Cool. And we're playing around with it. Yep. Play around with Linux. If it's your personal computer, careful, because it can blow up. But yeah, just careful with that. Cool. Okay, let's get back to this. Cool. So, we are in desktop. Okay. If we do ls again, we can see that again. We have this Minecraft world, image portfolio, and shell scripts. Okay, that is how CD and ls works. Okay. We went forward. It means we went from thingy to desktop, and let's go one more. Let's go to shell scripts. So I did thingy, desktop, shell scripts. Whatever I see here, see, it says script sh. Now, how do I go back? Or can we go back? Or are we trapped here for eternity? Because in the end, if we do ls, there is no other folder that, like a folder called back or go back. With ls, you can do something called L, which is listing or long, and A for all. Okay, let's just do A first. So this is called an argument. Okay, so this is the command. Command has arguments, and we'll check the arguments in a second. How do I know this? Because I've used this a lot. Okay, so I'm used to this, but if we do man, which stands for manual, ls, we can see that we have a lot of arguments. A, which is the one that I used, does not ignore entries starting with a dot. Okay, and I'll explain what dot means in a second. We have lots of things here. Okay, I wanted to use L as well. So if you go to scroll down and we go to L, uses a long listing format, which I'll show in a second. Okay. Cool. It says press H for help or Q for quit. Let's quit. Cool. Okay, I just pressed Q. That's it. Okay. 100% terminal. Okay. Cool. Now, you can see that we have two thingies here. We have a dot and we have two dots. What does this mean? If you see there in blue, remember what blue was. Blue stands for a folder. So dot is a folder. Let's go to dot. Ready? 1, 2, 3. Huh. We're still in thingy, desktop, shell scripts. It's probably just a bug. Let's just try it again. What does... So dot means here. If you do command space dot, it means I want you to run this here. Everything that has a dot, only a dot, it means here. Okay? Let's just try with double dot then. 3, 2, 1, and cool. We went back. So let's just recap. 1 dot means here. 2 dots. Let's go back. Okay. Let's do cd dot dot. Let's just go crazy, okay? Dot dot, cd dot dot. Cool. I can see that we don't have anything behind the /. Okay. If we do ls here, we will see lots of important things for, oh, let's do this. Because I can see that you're not seeing this. ls. Cool. You can see that we have some interesting folders, weird folders. Bin, dev, home, lost plus found, mint, proc, run. Some of them, I'll explain to you what they do later. Some of them not, okay? But basically what we're looking at are very specific folders, very important folders that make the whole file system work, okay? So without them, no Linux, okay? Let's go to home, okay? Let's just go to somewhere where we are safe. Okay, if you move something without knowing from, let's say, sys or root or opt, that's a lot of trouble. Okay, so fair warning, if you want to play with this, make sure to either do it one in a droplet or something similar like a server, which is not your computer. If it breaks, then you just restart it, or just get a new one and for a cheap price, and that's it. Or like a Raspberry Pi, you just format the SD card and that's it. Not your computer, because it'll be bad, very bad. Okay, cool. We are back home. Okay, LS, we have Bully and we have Pi. Okay, two different users. Okay, Pi is the first user, I am the second user. I have privileges too, so let's go to Bully. Cool. Back to the thingy. So we can see that /home, my user, it's thingy. Okay, what is a droplet? I set up okay, cool. This is an interesting question. What is a droplet? I set up a DigitalOcean server with a droplet. Is that a common term? Yes. Okay, so a droplet is only for DigitalOcean. Okay, a droplet is a server, basically. It's a server that you can access, and it's yours. You rent it from various cloud enterprises. In this case, DigitalOcean, could be AWS, Oracle. We have a lot of cloud servers that you can rent. You pay some price and you get a cheap version or a cool version. It depends on what you need. Okay, so that's a droplet. I'm used to the term droplet, but probably the universal term would be a cloud server. Okay, where you can access it and do whatever you want with it. So you can use a droplet to play with stuff, or a cloud server, because you don't have the specific hardware with you. And if you don't have it, wait a second, why do I have the banner on? There we go. That's better. If you have the specific hardware with you, you'll have to fix it on your own. If you're paying someone else, then it's just like a double click, destroy this server, create a new one, and voila, you'll still pay $1 a month or something. So yeah, that's why. Yeah, that's a drop. Great question though. Cool. Okay, so nice. So we can go back. We can go forward. What else can we do? Okay, so let's install stuff. Okay, and I want to install something which is funny. If we do Fortune, and we do this thing which is called a pipe. Okay, meaning everything that this command outputs, pipe it through here and send this output to cause-f tux. And now this is a problem. Okay, let me just go back and explain this again. Fortune is a command. It outputs something. That something is going to be sent through this thingy here to cause. Okay, which we'll see what it does. It says bash cause command not found. Cool. Let's get special permissions from myself and say sudo. Sudo means give me the infinity gauntlet and I can do whatever I want. I can break this thing. I can do whatever I want. Basically, I have no limits whatsoever. Okay, sudo. Not all users have sudo. Okay, you have to be a sudo user. It means you have to go into a specific file, which I won't show because I won't be responsible for whoever wants to use sudo and breaks their computer. It's a joke. I won't show it in this stream, but it's easy. You just go to a specific file. You just add into before your name, you just add sudo, and that's it, like that. It's as simple as that. But yeah, cool. Okay, so sudo, and let's do apt get. So for Raspberry Pi, for this distro, we use apt get to install stuff, okay, or upgrade stuff. I won't upgrade stuff because it'll take a lot of time. apt get install cause. Let's start with cause. I hope cause exists for Raspberry. Cool. There we go. It's doing its own magic, not typing everything. There you go. Let's do the same for, what was it? Fortune. Nice. Sometimes it asks, sometimes it doesn't. It says, do you want to continue? I have to write a capital Y, which is yes, enter. It'll do its magic. Let me connect my computer. Give me a second. Wait a second. Did you see that? totally unrelated to this. What is that? That's Jocelyn. Why do I have Jocelyn's? I don't know why do I have Jocelyn's cartoon. Well, that's funny. Cool. Okay, I have to change my cartoon later. That's funny. Shoutouts to Joss, by the way. Cool. Okay. So, let's see. So, we have our commands. If you use the arrows, you can move from previous commands that you've used. Okay. So instead of typing everything, I know I've typed it. I typed it before. I'll use the arrows. Okay. 1, 1, 1. This is the one that I want to say. Okay. Let's see how piping works. Okay. Okay. It says you look like $1 million, all green and wrinkled. Yeah. Yeah, I know. Let's try another one. Let's do the same thing. Fortune. You will soon forget this. I hope not. I hope none of you forget this cool stream, okay? But yeah, so what does this mean? It means if I type fortune here, just fortune without doing anything more. Huh. So what does fortune do? Let's do that again. Let's do man stands for manual fortune and read the first lines. It says, when fortune is one with no arguments, it prints out a random epigram. Cool, okay. Epigrams are divided into several categories, which are categories subdivided into those which are potentially offensive to those which are not. Okay. The fact that it told me that I look like $1 million, that wasn't offensive though. Cool. Okay, it says again, Q for quit. Q. There we go. Hey, by the way, if you are curious on how I clean the terminal, Control L. Okay, again, Control L should clean the terminal. If I do this and then Control L, voila, nice and clean. Okay, it doesn't mean I lost everything. I just scroll up and it's here. Okay, just FYI. Cool. What does cow say do? So man cow say says cow say generates an ASCII picture of a cow. In this case, I think they changed it to the Linux penguin saying something created by the user. Okay, huh. So can I say whatever I want? So let's just try that. Let's see if I do. Okay, this is the first time I try this, by the way. Echo is a command which is like print for Linux. So it's echo global hack week. Okay, and then we pipe this again. Piping means give me the output of a command and put it into the next command. Okay, and then we go cow say. Oh, what's it? Dash what? Dash ftux. Huh, interesting. Echo, aha. Why? That was weird. Let's just try it again. What? Try this like this. Ah, cool. Okay. I don't know. It bugged a little bit. Cool. Okay, so we can see that cowsay is a command that takes stuff that we given it and prints. They say it's a cow. I see here the little penguin from Linux, and it's saying global hack week. Okay, let's just try this one more time because it's really funny. What if we do fortune cow say green light in AM for new projects, red light in PM for traffic tickets? Yes, so true. Okay, cool. So that's piping. Okay, again, piping is this thingy over here. It's not a 1. This is a 1. Okay, it's not an L. This is an L. It's not a capital L. It's this thingy. Okay, cool, nice. Okay, so you know what sudo does. Okay, if I were to install something without sudo, it'll tell me permission denied. Okay, cool. Now let's start creating some stuff. Let's see how to create stuff, how to write stuff in the terminal. Okay, so first thing, and read all as well. First things first, something interesting as well. When you're working with this type of Linux format, so to speak, sometimes you kind of want to know how the computer is doing. Okay, in this case, my Raspberry. I don't know if I have enough RAM. I don't know if it's too slow. How would I know what's eating up the RAM, the CPU? Is there a command for that? And yeah, it is. We have top. Okay, if we enter top, voila, you can see this. Okay, it looks chunky, it looks weird, it is. It's not meant, so top is not meant to be very eye-friendly because it doesn't use that much resources. Okay, so when your computer is pretty slow, you would use top. Okay, if you have a little bit of resources to spare, I'll show you another command. But yeah, you have top. Okay, top tells us the amount of CPUs, tells us what's using CPU the most. In this case, it's top, basically, because I have nothing running in my Raspberry. System D, which is a daemon, which I'll explain later what a daemon is. And you can see that it's using at most 1.9 memory. This is Docker, and it just disappeared. It was like something that just popped up. It's normal. Okay, so this is how you would see how your computer is doing. Okay, what about something more eye-catching? Okay, let's do H top. Ah, this is better. So something that you have to know, the better looking it is, the more resources it'll take. Okay, so if your computer is running really slow and you use htop, it probably won't load. Okay, and you can crash the whole system. So you have to be careful with that. Okay. By the way, if you're curious, this all is taught in the production engineering fellowship. So if you have questions for the fellowship, about the fellowship, just ping me on Discord. But yeah, because I'm for whoever just joined, I'm a pod leader for the PE fellowship at MLH. So yeah, just ping me. But yeah, cool. Okay, so this is easier to use. Okay, so I don't know if you can I move myself? No, I don't think so. What if I do this? Is this better? Yeah, I think that's better. Okay, cool. So if I press on F1, you can see it says help. F2 setup, 3 search. So let's search something here. Cool. And I don't know, I'll type system D, which is something that I know exists. There we go. See? It's like magic, okay? Let's see, escape for cancel. Cool, okay. What about scrolling? Oh, I can't scroll. What about IO? Oh, cool. So we have 2 here. PID stands for process ID. Okay. 1 is root. Okay, you can kill all the PIDs except 1. You would kill you would just turn off the whole computer. But yeah, 1 is untouchable. Okay, I think it doesn't let you kill 1 even if you're a sudo, just because, you know, protection. But yeah, cool. So every single command, every single thing running on your Linux computer has a PID. On Windows as well, and on Mac it's Unix, so it should be the same. Okay, everything has a PID. It says here F9 for killing. We will just unalive this. Okay, wait a second. Yeah, let's unalive htop. Let's see what happens. So F9 for kill. 3, 2, 1, and okay. It says send a signal. I'll send a signal. Not 9. Okay, so try not to use sick kill. Sick kill, what it does, it kills the process, but it doesn't close it naturally. Okay, that's when something is really, really, really going bad, and you need to get rid of it. Okay, that's when you use sick kill. Do not use sick kill. Okay, let's go and use. Let's see if I can find. Was it 22? I'm not sure. I forgot because let's see. Let's sick against. Yep. Let's use number 2. Enter. Ooh. We just killed the process. It means htop by itself was running in a process number. We said, hey, kill this process. Whoop, htop disappeared. Okay, that's not the way of closing htop. Okay, if you're gonna close htop, you do Control-C. That's it. Usually, to cancel stuff on Linux, you should use Control-C. Okay, cool. Because there's a command which is yes. Okay, it'll bug all about everything. It just types Y's, you know, up until the end. I don't know why. If you type Control-C, I'll do it a lot of times. Yep, there you go. Cool. Control-C kills stuff. Okay, cool. Nice. So nice. So we know about that. Let's go to CD. Where were we? The desktop. Let's go to. Okay, I have something called shell scripts. Okay. Again, blue in this case, and usually it's a directory or a folder. How do you remove a folder? So there's a command which is called rm. Rm stands for remove. Okay, so if you remove something, you'll delete it. Okay, it should be easy, right? Let's just not read the manual. Manuals are for people who don't know Linux. We know Linux. Let's do this. Shell scripts. So we should read it. Man, all right. Let's see what can help us. Recursive, remove directories. Ooh, okay. Well, that's interesting. So we would use rm only if we wanted to remove files. If we want to remove directories, we have to use a recursive. Why is that? Well, it's simple. Directories. Let's see. Let's remove this one. Okay, script. Okay, cool. So see, ls, I had script.sh, remove script.sh. I did ls, nothing happened. Okay. This is an interesting question. Okay, did you make all of these folders yourself? On Windows laptops, there is a desktop folder by default, but I'm guessing you went up set up server Raspberry Pi, so you have to make all the folders yourself. Nope. So when you, okay, great question. When you are setting up your Raspberry or Linux computer, okay, independently of the Linux distro, you'll have the folders. Okay, so shoot. No, sorry, my bad. There you go. If we go to this part over here, I didn't create by myself bookshelf, desktop. I think this one as well. Videos. I'm sorry, it's in Spanish for some reason. I live in Mexico and it just did it in Spanish. I hate it because it has bookshelf and descargas, which is downloads. So downloads, documents, images, and music. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I didn't create them. Raspberry did it for me, or Linux did it for me. Okay. So as far as this goes, no, I didn't create them. I created this one, and this one. Okay. And I'll show you in a second how to create them. But yeah, it's like, so, okay, probably at the end, I'll try to connect my Raspberry into my, no, I couldn't show you. I won't be able to show you. Yeah, so my Raspberry has an HDMI port, which can connect to my other, wait a second, why do I have my camera off? Can connect to my screen, okay? So I can use my Raspberry as I use my Windows machine, you know, with icons and everything friendly. I try not to use it that way because it's counterproductive. I wouldn't use a Raspberry which has 4 GB of RAM and a not very powerful CPU for something like Word or typing or anything like that. Okay, so if I connect to the HDMI, I can see my desktop, and inside of my desktop folder, I can see the whole desktop. Okay, so as Windows, I can play with it. There's like a little bin here, which is the trash bin and all of that. So yeah, again, answer to your question, not all of them. Okay, these are created by default. These 3 I created them my own. Okay, so but yeah, it's like in Windows. Okay, you just open your computer, it sets up on its own. Voila, you have it ready to go. Okay, it's not that you have to go one by one. Okay. Cool. Great question, though. Nice. Okay, cool. So let's go to, you can move, by the way, into multiple directories at once. So you have to make sure that they are parent, children. Okay, so we know that inside of desktop, we have shell scripts. We can type shell scripts and voila. It's not that I'm typing especially fast. It's that if I type the first or 1 or 2 letters or characters of the name and I click on or press on tab, it auto completes for me. If it doesn't exist, it wouldn't do it. Okay, so in this case, I have nothing. If I do cdh nothing happens. Okay, cool. Okay, we have shell scripts. Okay, so based on what we did, which is removing a file, then we will be able to remove shell scripts folder without using, recursive, right? Because in the end, we have nothing inside. So let's just try it. RM, shell scripts. 3, 2, 1. No, it still says it's a directory. Then what is the difference between a file and a folder? Like, a folder is just something that connects to files. It shouldn't be different. In case of Linux, remember that we have these things. Voila! We have 2 folders that, yeah, cool. Okay, so, other guy, check back on Monday. Linux is actually part of cloud, so it's kind of important. Yes. Cool. Okay, nice. So folders are never empty. You can never delete these 2 things, okay? So we have to remove it by doing rm-r. And then F, I try to use F for forced, just because sometimes it throws you like, hey, it has a lot of files. Do you gonna want to go one by one, telling it which to download or to remove? Just, I don't want to see that. So rm-rf shell scripts. Cool. No errors. It means something happened. Ooh, no more shell scripts. See, I have my Minecraft installer, my world, the MLH portfolio, a runner, but I don't have any shell scripts. Cool. So we know how to remove folders. Let's create one, okay? Make dir. Okay, mkdir stands for make directory. Let's do shell scripts once again. No error, means something happened. Ooh, shell scripts once again. Then let's go to shell scripts. ls -a. Ooh, see? Folders that are created by their own, okay? Cool. Now that we have that, how can we write stuff? So we know how to create stuff, how to delete directories, how to delete a file. We know how to traverse going back and forth with the file system. How do we actually create stuff? Usually everything, or that's what they say, everything in Linux is a file. Okay, means that you can create from anything. Let me just turn on this light. Cool, can I have no sun? There we go, nice. You can literally do anything from a file, okay? Let's do that. Touch. Touch is the command to create or open files, okay? Let's do touch hello.txt, okay? Always try to add that, like what type of file it is, okay? Okay, no errors, it means something happened. Oh, we have an hello.txt. Then how do we actually go to it? That's easy, right? Like cd hello. See, if I try to autocomplete, Raspberry tells me, nah, there's something that you're doing wrong. I think Raspberry is wrong. Let's do hello.txt. cd hello.txt. Oh, yes, not a directory. So there is another command that we can use for accessing files and editing files. Okay, we have a lot of them. Okay, some people use nano, some people use v. I don't like any of them. I like vim. Okay, vim is my personal favorite. I'm used to it. It's, for me, it's easy to use. If you want to use nano, if you want to use v, it's up to you. All of them do basically the same thing. Okay, let's do vim and then hello.txt. See that? If I autocomplete, it does it for me. It means that most likely what I'm trying to do with this command will be correct. 3, 2, 1, enter. Ooh, okay. We have something like in Windows would be a notepad. I guess in macOS it's called Notepad too. It's just a blank file. Let's do hello. Oh shoot. For Vim, you have to press I before typing anything. Okay. So if I try to type, oh, I forced it. But let's do this. If I do K, L, O, okay, cool. Yeah, we have to do I. Okay. So I stands for insert. Cool. So let's do hello. My name is Willie. Nice. Meet you all. Cool. Nice. How do we actually save this? So there is no X button. This X button is from Windows. So this is from the terminal. I would close the terminal. That wouldn't be it. So again, no mouse out. Okay. What can we do? So if you can see it says insert here. It means we're in insert mode. For Vim, if you want to change from insert mode to command mode, escape. Okay, so press escape. Ooh, okay. So I cannot type anymore. I can just write commands. Usually for Vim, commands start with colon, and I'll do W for write, Q for quit. Okay, again, we're in insert. Okay, I can still write some stuff. Aligai as a cool question. Cool. Escape. Colon. W for write. Q for quit. Enter. Ooh. Again, if no errors, then something happened. It looks the same. Should be the same, right? Like, how can we know? How can we see what's inside? Easy, right? Let's just do Vim again. Vim, hello. Ooh, there it is. Okay, nice. If you just want to read a file, I don't think it'll be a good idea to do Vim all of the time, because if you want to exit the file, you have to do escape. The colon. If you didn't write anything, you can do Q. Okay, it won't save anything because you didn't do anything. And voila. Okay. What other commands can we use to read files? Cat. Cat reads a file and prints it for you. Okay. And you gotta be careful with cat though, but I'll go into that. Okay. Cat, hello. 3, 2, 1, and ooh, there we go. Hello, my name is Willie. Nice to meet you all. Aligai asked a cool question. Nice. So we can read a file with Vim with cat. Okay. What happens if I just want to read one line of the file, or 2 lines, or the first 3 lines? Well, let's use piping. Cat hello.txt. Okay, so first command that we'll be using is cat. So I want you, Mr. Linux, to take everything that's inside of hello and send it to another command, which is head. Okay, head gives us the first lines. If you don't run it with arguments, it's the first 5 lines. I think it was n-n5 that you can change the number. So let's do -n1. 3, 2, 1, and ooh, see that? Even though we did cat went from reading the whole file, sending it to head. Head said, hey, wait a second. I'm just getting a command here that says only output the first part of the first line. Second line was ignored. Third line was ignored. Let's do the same thing for 2 lines. 3, 2, 1, and ooh, can see? First line, second line. Let's do the first 3. Ooh, what happens if we do the first 4? Will I throw an error? I'm out there. Oh no. Okay, so from your last line up until the amount or the number that you want, it wouldn't actually throw an error. Okay, it would just throw or show the whole file. Okay, let's clean this. Cool. Okay, I said careful with cat. Why? Well, if you do CD, by the way, you type on CD, you go back up until this thingy. Okay. Let's go back to the interesting folders. Okay, which are these ones. Okay, again, these folders are all made by the operating system, not me. Okay, cool. Let's go to CD dev. Cool. Okay, so this doesn't look really good. What does all of this mean? Okay, I'll go into it in a second, but I kind of want to see. I want to find a huge file. Okay. Work. Give me a second. Okay. Cool. Let's get out of here. Let's see if we can go to proc. Let's go to etc. etc is easier. Okay. Cool. Now, if we do cat local dot alias, I don't know what that is. Alias. Let's do local.gen. Locale.gen. Ooh, see that? That's the problem with cat. It shows you everything. It's a lot of things. Okay, if you just wanted to read the first 5 lines, then let's do it again. Okay, cat. What is the name of the file? Okay, cat locale.gen. Pipe into head. Let's just do head without any more arguments. 3, 2, 1, and first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of the files. Okay, so we can see the first 10. Okay, let's just change that again. -n to 15 now. Ooh, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14. I should have miscounted, but it should be 15. Okay, cool. Now, careful with cat, because this wasn't a large file. Like, they're huge binary files. If you do, hey, I kind of want to see what this contains. Boom. It never ends. Okay, and you have to wait like 15 seconds for it to output everything. So careful with cat. Okay, you can also do, I think you can also do head locale.gen. Yeah, cool. You can also do the whole head, like just head. I kind of wanted to show you as well how piping works. Okay, cool. Now, again, CD in any position of the file system or location, it will send back to you to this thingy, okay, which is where desktop, downloads, documents, images, and music is. Okay, cool. I did cat part, and yeah, it was pretty big. Yeah. If you do cat something and it's huge, it takes a lot of time, and sometimes it bugs a little bit the computer just because it's binary, and it'll show like weird shapes. If you see weird shapes, it's a binary file. Okay, let's just take a look at the one, like just for fun. Okay, cd cd.dog ls should be cd bin. Cool, ls. Okay, let's start with understanding the file system now. Okay, we went to bin. Bin is where all of the binaries are located. Okay, it means every single command that you can use is located here. Okay, and you may say, Bully, that's too much. Like, if I want to find Kause, I'll have to scroll up and up and up and up and up. DCO. Ooh, Kause is not here. That's interesting. I don't know. CD should be here. CC, CD, create, CD. Okay, then it's not here. Then give me a second. Oh, shoot. I just think, cool. Should be, and it's not bin, should be in CD. Wait a second. Was it? It's in user, yeah. CD bin. Yeah, cool. Okay, so sorry. So there are 2 bin folders. The first bin is specific, only readable binaries for the OS. Okay. user bin is where all of the commands that you can use are located. Okay, let's take a look at it. ls. Again, we have a lot of things. Let's look at cowsay. Cowsay should be here. Please don't fail me. And it's not here. Interesting. I don't know where cowsay is. cd should be here, by the way. Let's see. cp cd should be here. If it's not here, then this is really weird. It should be here. cc cd create profile. I don't know if it's these three, okay, but yeah, these are all of the commands that you can use, okay. And if you try to, okay, let's do agnostics, okay. Let's see. Oh, axter. Okay, cool. So let's do cat axter. Or cat zstd grep. Okay, cool. This is a bash script. Okay, I kind of wanted to find a binary file. Let's just not find a binary file then. Cool. Okay, so cool. Let's do this. Okay, cool. Now, before going into the file system, there are two commands that I kind of want to show, which is, let's see if we can find interesting things in, yeah. Okay, cool. I know where. cd, cool, cd desktop, and we know we have JavaScript. There you go. Now, let's say I want to find, let's use something. Vim, hello world. Oh, hello. Okay. And let's do 1, 2, 3, 4. Cool. 1 up until 6. Okay. Now you can say, hey, let's imagine that that's a very, very, very big file. How can I find specific words from a file or from any command? If you do cat, hello, okay, again, cat shows or prints everything that's in the file. Let's pipe it into grep. Grep grabs. Okay, I don't know what grep stands for exactly. I know it sounds like grab, so you can remember grep as grab. Grep, without the thingies, you can do 2. Ooh, see? It found a 2. Let's put a number that wasn't there. Let's do 9. Nothing. So if grep finds something, it'll output it to you. If it doesn't find anything, nothing will be outputted. Okay, one more time. Let's do something more complicated. Hello. Bully. Was it with capital B? Oh, there you go. Cool. Capital H, by the way. But yeah, it's case sensitive. So, see, it outputs the line where what you're looking at or looking for is. Okay, let's do something more complicated. Let's do stat dash tulpn. Cool. Netstat allows us to see every address that's being used for now. Address and port. Okay, just FYI, this one and this one are the same. This is an IPv6 address, IPv4 address. This is an IP address 000022. Port 22 is for our, or in this case, the connection of the SSH. It means the connection from my Windows computer to the Raspberry. Okay, that's why it's listening. Okay, let's say we didn't see this. Let's do the grep thing. Let's do netstat tulpn pipe again, grep into, want to find :22. Everything that has :22 in it. Cool. See, not all process could be identified. No known process info will be shown. Careful with grep also. Okay. See, it shows everything that we need that has :22. Okay, that's what grep does. Grep is very, very helpful. Cool. Now, that's been a lot. I know it's a lot. Okay. Now let's have fun with introduction to the file system. Okay, now we know how to move, we know how to create, how to lead, how to read, how to check the processes. We know a lot, but we don't know what some things stand for. Okay, so let's go to cd dot dot. Oh, by the way, if you want to go to a important folder, you can do it without moving. Okay, so if you are here and you want to go to shell scripts, you can't do it because you have to go first to desktop and then shell scripts. But if you want to go to etc from here, like this, see, we moved. etc is 2 steps behind. Okay, cool. Now, FYI, okay, that's a little trick. Cool. Now, we have in etc lots of things. Okay, etc is used for configuration files of the computer. Okay, we have a lot of things here, a lot of things. Something interesting from etc, we have systemd, which is where daemons are located. Okay, cool, and it's in system. Okay, cool. So etc systemd system is where all of the daemons, all of the services are located. What's a service, you might ask? A service is something that will run when the computer turns on. Okay, so just as a quick example, for my Minecraft server that I want to do, and hopefully I'll have done, is whenever I turn on my Raspberry Pi, I don't want to connect to it SSH into my Raspberry Pi, and then, oh, I want to start the server. Yeah, I have to do that manually. You can do it by a service. In this case, I wrote portfolio service. Okay, let's see it. Cat portfolio service. Cool. So, personal advice. You can use cat for any other types of files. If you want to read code, try to use Vim. Okay, I know I said don't use Vim to read files. Just use it when you're reading code. You'll see why. It's way better. See? Formatted with colors and everything. Okay, so you can see this. This is a file that controls a service that whenever I restart the computer, it'll run. Okay, if it's restarted, the service restarts, it'll run automatically. Okay, just let's read it, skim it pretty quick. Description, it serves a portfolio site. Okay, after network target. Okay, the interesting thing is here. Working directory, it's located in home, bully, which is where the desktop is. Remember, instead of going into script or shell script, was it? We go to MLH portfolio. Inside of it, Linux, I ask you to do this. Open Python, open the Python environment, run Flask, which is a library to control, let's say, web pages for Python, in host 0000, which is an IP address. Okay, that's what it does. Okay, so you can see, let's not touch this. You can see that everything, again, everything in Linux could be considered a file. Okay, everything that you need, it can be written in a file. Okay, so let's see how services work. If we do sudo, it means infinity gauntlet. It means give me the power system control status. It'll tell me all of the services that are running right now. Okay, I can see we have modem manager, we have Bluetooth. Okay, so I have a Bluetooth service. It means my Raspberry has the ability to have Bluetooth. Containers, which is for Docker. Cron jobs, which is something like a service, but it's a file that executes something after a certain amount of time. So you can do cron, say hello in the terminal each 5 minutes. Okay, each 5 minutes or every 5 minutes, you'll see hello, hello, hello. That's a cron job. Okay, different than a service, because if you restart that computer, the cron job won't run. Still exists, it won't run. You'll need a service to run the cron job to do it. Make sense? So hopefully it makes sense. But yeah, we have interesting things. We have Docker here. We have Docker service. It means Docker is running in the background. Okay, probably not running anything on itself, but it's running. Okay, cool. To get out, Control C as always. Cool, nice. So that's about etc. Again, etc is for the system config files. Okay, let's go to var. Do ls here. Ooh, we have interesting things here. Var is for logs and cache. Okay, everything, if you get a big error, a huge crash, you want to see what the heck happened. Let's go to log. What? cd log. Okay, cool. That's a very interesting question. macOS, even if it's a Unix-based OS, it doesn't mean it'll have the same folders as Linux. Okay, I'm pretty sure you have systemd on Mac, but it's not called systemd. I'm not sure. Okay, I don't use Mac. I rarely use Mac, but I'm pretty sure it's called something else. You should have the folder because it's kind of the same idea of how Mac and Linux run. Okay, but it should probably be called something else. Okay, just yeah. So if you find it, let us know. Okay, but it's probably not systemd. Okay, or it's probably located in somewhere else. I don't know. I don't use Mac. Like again, I have a Mac here. Where is it? Oh, can you see it? Ooh, you cannot see it. Okay, there it is. Never used it. Like I've used it for I had Ubuntu here. I know you won't like it. Yeah, that's I didn't want to partition my Windows, so I partitioned the Mac because no one uses it in the family. So yeah, I'm sorry, but I've never used Mac before. Okay, so I've used Mac, but not to that extent. So it's probably called something else. Okay, great question though. If we do log, ooh, we can see lots of things here. We have a journal. What if we go to journal? I like Ubuntu too. Ubuntu's great. Ubuntu's great. Cool. ls. Ooh, cd8. Ooh, what is it here? Oh, wow. You see, we're just going into the rabbit hole. You can see that all of these are white. It means they're files, not executable, but files. Let's just read something. Let's just read the system journal. So, sudo, okay, grant me all of the permissions. Cat system.journal 3 to 1. I think it'll have a lot of output. Ooh, there you go. Great, that's a binary. Okay, whenever you see this, that's a binary file. Okay, you won't be able to read it. You're not a machine. You can see some interesting stuff. Mesh is starting, man DB service. Okay, you can read interesting things. Okay, let's see if I can find some interesting thing. Let's do sudo cat system journal. Again, give me everything, pipe it to what? It happens sometimes. Wait a second, it happens. Let's do, there we go. This, and then we go pipe, and then let's just do grep. Let's see if we can find systemd. Ooh, binary file matches. See, if it's a binary, I can read it as a normal file. Cool. So careful with that too. Okay, cool. We found a binary file. Let's see if we can read the logs. If not, I'll have to type another command. But cat system at there we go. D3 yeah dot journal. If I do this, no, cool. Okay, great. Let's do then another thing. Sudo system journal. Yeah, cool. This is the Linux journal. Okay, it lives. This thing, everything that's said here lives here. Actually, it lives here. So inside of journal, inside of each time that you turn on the computer, it creates a journal. It means everything that happens is being written into a journal that you can debug and read to see what happened. Okay, sometimes the computer will turn on and then turn off. And you said, okay, I installed Docker, I'll just uninstall Docker quickly, and then I'll just read the journal. Journal can contain interesting stuff. In this case, we're just reading it lines 1 to 24, but we can see reserved memory, create CMA memory pool at first bit of memory. Okay, actually, you can see putting Linux on physical CPU. Oh, wow. So we get from step 1, which is turning on my Raspberry, up until now, what I'm doing now. Okay, let's try to do that. Okay, let's do sudo journalctl, and then let's just grep, or actually instead of head, let's just do tail. Tail exists too. Ah, cool. Okay, see, the last thing was a binary. Why? I ran a command. The command was run, and the command was a binary. Okay, let's see if we can do tail -n10. Can this work? No, it won't work because I've used commands before. Okay, so we cannot see all of the journal. We have to go see it like this, and then probably like this. Not sure. There you go. Lines, scroll down. It's a never ending. Okay, you can see the lines. 153 out of 176. We go down. 205. We go down. But if you can see, it talks about everything that happens inside of the computer when it's booting. See? Ethernet, everything that happened. Okay, so that's how you do it. Again, let's do that again. All of this journal lives here. Why is it stored in binary? Because if you store all of that in string, you're out of memory. From the booting process up until now, you'll be out of memory. Okay, it's stored in binary. You cannot read it by your own. So you do sudo journal control. Okay, I don't know if that exists on Mac though, but do try it and let me know. Oh, there we go. Again, okay, that's how you can troubleshoot what's happening to your computer. Something helpful is that sometimes errors are in red. Something that you do not want to see when you're working with Linux in a terminal is red. That's the worst thing that can happen because it's like a huge error. Okay, but yeah, cool. Okay, again, etc system configuration files. var, we can find cache and journals. Okay, cool. Now let's go to cd bin and then sbin. Do I have sbin? I think not all. Let's try to find it. ls grep sbin. Ooh, there is no sbin. Okay, cool. So in bin, you can find all of the essential system binaries. Okay, all of these are essentials for the system to live. Okay, these are commands that the system uses. Actually, we have tree. We can use tree. It shows every single file and where it connects and what it has from where you are at up until the last point. Okay, so it does literally a tree. Okay, 2 directories, and it has these amount of files. What happens if we do 3 here? Whoo! You can see this. We can find. Oh, cool. Here we go. PyCache. Okay, so something was using PyCache. If we scroll up, we have to see what it is. I hope it doesn't take that much time. Nah, it'll take a lot of time to go up. Okay, cool. So let's do tree again. And you can see, oh, let's not do tree again. Okay, let's just see that tree connect stuff. Okay, we have from something that was connected before to lib64 to lib. Okay, tree gives you from where you are at down, all of the files, all of the folders connected, okay? I've never used tree before. I don't know. It's just, if you need something, you do htop, and then, I don't know, you just click on something and do F5 for tree. This doesn't have a tree. Cool. F5. Oh, actually, you can see it. How can I do this? Oh, there we go. F5. See, there we go. So you can see that user libexec accounts daemon is running user libexec accounts daemon in another one. See, it's like a tree. Okay. So I've never used a command tree before to debug something. It's hard to read. Use htop instead. Okay, cool. Now, what else? Let's go to user. Okay, everything that's related to, in this case, me. So, Alice. Ooh, we have games. Do I? I'm not sure. Oh, okay. Interesting. So Causa is for the computer, for Linux, a game. That's very interesting. Cool. Let's do it again. Fortune Causa -t -f. I'm sorry. What was it? -f -tux. 3 to 1. Let's see what it says. Classic is something that everyone wants to have read and nobody wants to read. Ooh, okay, interesting. So that's for Raspberry, for Raspbian, Causa, and Fortune commands are games. I didn't know that, by the way. I thought they were commands. Cool. We can go to bin or sbin. Let's go to sbin. Okay. Let's see if cd is here. Let's do that. ls again. Ref. Let's see if cd is here. Oh, cd is not here. I'm not sure where cd is, by the way. It should be in bin. I don't know why he's not in bin, but yeah. Everything related to us, or in this case to me, it's in user. Okay. Every command that I'll be using is in user. Where is cd? I'm not sure. I thought it was in bin. It's not there. At least for Raspbian, it's not a command. Okay. Cool. Okay. And I don't think they're okay. src, I think. Yeah, no, nothing. That's not important. Cool. Okay. So everything related to user is in USR. Okay. Every library that you download, okay, such as Causa, Fortune, if you want to download Docker, if you want to download, I don't know, Python, everything, it's inside of user. Okay, everything. So that's easy because anything that's, let's call it, potentially harmful, if you delete it, it's located in bin. But everything that you downloaded and that you can delete, even if it's a command, it's located in user, bin, games, or probably sbin. Okay, cool. Never, ever, ever, ever delete something from /bin. Never. From user bin, go ahead. From /bin, never. Okay, because the computer will go crazy. Cool. Woo. Okay. Last but not least, let's clean this up. cd proc. What does proc do? Proc, such as var, gives you a little bit of a system info as well. Okay. Now, these numbers, I think, yeah, okay, cool. I remember it. Proc gives you every single process that it's running in the computer in real time. Remember what one was? We do htop, or actually we could do, shoot, I forgot the command. Let's do htop. Cool. Click on PID. PID1 is root. Okay. It means number one manages your computer. Number one is Linux. Okay. Imagine it's you and Linux. You are not a process. Linux is. If you kill one, computer will go bye-bye. Okay. So don't kill one. Leave one alone. Okay. You can see one here. Cool. You can see one here. Every single process running in the computer is here. Let's see one. Oh, see, interesting. If we go to one, we're looking inside of a process. See, let's do ls. Ah, there we go. Cool. So it's inside of a process, and you'll have everything related to the process. Okay. I do not recommend going into these and manually changing them. Okay. I would rather you go and kill the service or the process and then fix the code in another part rather than moving it here, because this is real time. Okay, cool. Now, symbolic links. Yeah, let's explain them. Symbolic links are, let's easy explaining it is a link from one command to another, not directly connected. Okay, it's like a link that connects one program with another one, but it's not directly connected up until they need themselves. Makes sense? It's like the easy way to explain symbolic links. It's a little bit confusing, but that's how it works. Okay, cool. Now, ls cannot read symbolic link, cwd, root, or x. Okay, let's see if we can do it with this. Ooh, interesting. Oh, no, we cannot do it. Oh, I thought we could. Okay, cool. Now, you can see that ls-l gives us interesting things. Let's go into a different folder where it's not that crowded. Cool. And there we go. Nice. So ls-l 3 to 1. Ooh, okay. Now this gives us more information. The important part of this is this. What does that mean? Oh, that's interesting. Okay, so we have the first line. The first line could be three options. One could be nothing, like this, which is called a file. That means it's a file. D, it's a directory, blues, D, blue, and also blue, D. File, see, runner, it's nothing. And third thing that we can have, it's an L, which is a link. Okay, we don't have links here, so no worries. Okay, now the next characters, what do they mean? Okay, I'll write that down here. Echo. R stands for stands for read. Okay, R is for reading. X stands for, what do you think? It's, wait a second, I just lost the word. Execute. Cool. So X stands for execute permissions, and W stands for, try to guess it? Right. Cool. So again, R read, X execute, W write. Okay, so it means install pydocker minecraft.sh has permissions to read, write, and execute. But you can see that we have different R's. So we have an R here, an R here, an R here. We have X here. Why do we have like 5X? It means for every after this, which is the thing description, which is either a directory, a file, or a link. A link stands with L. Okay. You count 3. The first 3 is for the owner of the file. In this case, me. So I can read, write, and execute. Okay. I can do all of those 3 things because I'm the owner. Okay. The next 3 stand or are for groups. Okay. In Linux, such as in Windows and in Mac, you can create groups. It's more for enterprises, or if different people are using the computer, the same computer, and they have different usernames. Each username could be a group, or you could group, I don't know, people who work in IT with one group, mechatronics people in another group, robotics people in another group. Okay, that's how you can group things, and then you can assign groups to have different permissions. Probably IT people would have all of the permissions. Mechatronics people would have reading and writing, probably not executing. You know what I mean? That's how you control it. Okay, and the last three are for others. Others usually means commands that will be using them. Okay, so if you create a file, a script that runs this from another script, it means I create here a script. Okay, let's do, I don't know, touch. Oh, you can do Vim. Okay, if you do Vim, if it doesn't exist, and if you do Vim, it creates it. Okay, automatically. But do use Doge for sometimes. Okay, I don't know if you do here run I don't know, run install. Okay, let's write it. Of course, that's not shell script, but you know, just an example. We run script to run install. Then we need it to have the execute permissions. In this case, it has it. See, it has X. Okay, if I remove the X, something will happen. Remember that I told you everything in green is executable. Let's change permissions. chmod. Chmod changes permissions. Let's do minus X, which is remove all of the executing permissions for install. Okay, 3, 2, 1, voila, no errors. Ooh, see, it's not green anymore. And if you see, we have no X, no X, and no X. It means this thing, if you try to run it, it won't, because it doesn't have executing permissions. Let's do the same thing. Instead of minus, plus X. Ooh, cool. Ooh, cool. No execution permissions, execute permissions, X, X, X. See, same thing with the others, okay? If I want to do minus R, I don't want anyone to read this file. Why? Because I don't know, it's a love letter for someone. Ooh. No R, no R, and no R. See that? You can control permissions using GHMOD, okay? There you go. Cool. Now, this will be helpful. Why? There we go. Let's start bash scripting, okay? We have 40 minutes. Let's start with some bash. Bash is used to automate stuff, okay? Bash, as you'll see, it's a little bit of funky to write. It's not very friendly to write. It does a lot of things, but try to keep it simple with bash, okay? If you want to automate, I don't know, a service. If you want to, I don't know, get an image from, or get a URL, download, I don't know, all of the mods from Minecraft, and moving them to another directory, use bash. If you want to do something a little bit more complex, bash becomes not unusable, but it's just difficult and tedious to write. So you can go to Python or C++ or any other programming language of your, whatever you want. But don't use bash for stuff that you can do with Python. Okay, if you want to, I don't know, automate stuff, complicated stuff, Python. If you want to move certain files from one folder to another, bash. Okay, makes sense? Bash is pretty quick. If you do stuff with bash, it'll be pretty quick. Just keep in mind that if you write bash, it's a little bit funky to write sometimes, okay? Cool. Let's go to scripts, okay? There we go. So we have hello, okay? Now, again, we can create files and open them at the same time with Vim, okay? So Vim script.sh. sh stands for shell script, okay? Cool. Now, we have Vim, good old Vim. Click on I or press on I. We have the insert part. Let's see what we can do. Remember that I used echo. Echo is like the print. Let's do echo. Echo. I'm having fun. Cool. Again, escape for Vim. colon, W for write, Q for quit, enter. And then to run it, /script. Permission denied. What does this mean? Whenever you create a folder, or a file, and you want to run it, make sure to have executing permissions, okay? There you go. It's in green now, okay? It means that if I do this, voila, worked. I'm having fun, okay? Now, can you use variables with bash? Of course. What if we do name equals Bully? Okay, that's my name. By the way, careful with space. If you do this, won't work. Should be like this. Okay, again, that's why bash is not so, it's funky to write, okay? Just because if you add spaces so it looks better, won't work, okay? Cool. Now, echo my name is $May. $sign means I want to refer to a variable, okay? Yeah, definitely use the Raspberry Pi device. Raspberries are really cool. Easy to use. If you break something, you just, format the SD card and that's it. Like it's really easy, and it's a personal server for you. So it's really cool. Okay, cool. Now let's do script 3, 2, 1, and my name is Bully. Oh, see, now we can use variables. Okay, believe me, if you add a space, 3, 2, 1. Oh, could not find name. It means you don't have to write spaces. Okay, just be careful with that. Okay, Vim script careful with this. There you go. Actually, you can see it's bluish, which is a variable. Okay, cool. Now, what about IO? Okay, I want to ask for a name. Let's do echo. What's your name? Let's do this, and then let's do name or read name. Okay, it means first echo what's your name up until I write what my name is, then you'll echo my name is Bully, or when my name is whatever. Okay, let's do this. Cool. What's your name? Okay, you can see you don't have this thingy, which is like the prompt for you to add commands. Bash is waiting for you to write something. I don't know. I'll put my girlfriend's name, okay, which is Jimena. There you go. Did I just lose my Raspberry? There you go. My name is Jimena. Cool. Okay, so this is how to use variables in Bash. Okay, cool. Now let's go into, okay, I don't know, 727. Okay, I think we have cool. Okay, we have some time. Okay, now what about if else statements? Do we have if else statements? Yes, we do. Let's do echo. Good. Enter a number, please. Cool. Now, then after we ask for the number, we read number. Okay. Anything that we write will be stored in number. Okay. Now, if, okay. Careful with spaces, by the way. Again, careful with spaces, huh? In this case, you have to leave a space. You have to have spaces in between these things, okay? We do S number, okay? Dash GT. What does GT stands for? Greater than, okay? So if my number is greater than 10, semicolon, then, see, there is an indentation there, careful too. That's why I love them, because it does it for you. Echo. That's a big number. else, then echo that's a small number. And to finish, p. There you go. Here we have a question. Will the previous bash file still work even if you don't write a name, like spaces or numbers? Yes, because anything that you write is something. Okay, so spaces \s, a dot will be a dot. Okay, so we're not comparing, or in the previous one, we would be not comparing if it was a string or numbers. It just print whatever you give me. So if I give you nothing, or 3 spaces, or like nothing, it'll just give you nothing. So that's how it works. Okay, cool. Now, WQ. Let's do script. Please enter a number. Let's do 2. Oh, that's much smaller. What about if we do the same thing with 11? Oh, that's a big number. See, now you don't have with bash, you don't have to explicitly tell bash what type of variable it will be, meaning integer, float, string. Okay, it kind of gets it on its own. That's cool. At the same time, you have to be careful because this one just checks for numbers. Okay, if you want to do like equal instead of this one, would be eq. Okay, and let's do that's 10. Okay, so let's do this. See, that's a 10. Okay, if we do the double equal, okay, it will work, but it wouldn't work for numbers or for strings because it just checks if the type is the same. Okay, so double equals in this case, or the admiration sign, which is this one, like this thing wouldn't work because it would just tell you if the type of the variable is the same or not. Okay, so we do int here and we do string here, then it would be true. If we do, this would be false. Okay, just careful with that. Okay, cool. Now, what else can we do? So, let's do functions. Okay, cool. So we can do functions. Let's do vim script. Let's just delete everything. If I'm not mistaken, you do colon, this percentage sign, and then D, it deletes everything in Vim. 3, 2, 1, and ooh, there you go. Cool. Now, oh shoot, sorry. Talk. Was it with space? I'm not sure. There you go. Now, let's do a function that, well, just talks. Okay. Echo. Hello. S1. What does S1 or what does $1 stands for? It stands for the first argument that this thing is going to receive. Okay, you don't have to explicitly put it here. You can put $1 and it's the first argument that it will give it to you. Okay, cool. So let's do read name. Let's do name, and then let's do talk with the name. Okay, again, talk like a normal function, like in C. Echo hello, $1 again means the first argument that it's going to receive. Read the name and then use talk with the name. Cool. Hopefully this works. 3, 2, 1, and oh, why nothing happens? Oh, it's waiting for anything. Okay, let's just see if it works with my name. Oh, what did it happen? So interesting. It's because it's not referenced as a variable. Remember what referenced it as a var? Like what a var makes a var? $. Okay, not when you start the variable or create the variable, but when you reference to it. Okay, let's see that in action. What? 3, 2, 1, and ooh, there we go. Okay, careful with that because it's easy to get it wrong the first times just because you're used to, you know, if the variable name is name, you just do use name with talk and that's it. With bash, remember to $sign it so it's reference to the variable. Okay, if not, it'll be a string or an error. Okay, cool. Nice. Okay, so how? So we can talk, we can compare numbers, we can do lots of things. Can we use commands, Linux commands inside of bash? Answer, yes. Let's do something with that. Cool. Again, if you want to delete everything, escape, colon, the %sign, and then D. 3, 2, 1. Ooh, cool. Nice. Okay. So let's echo. This is how much CPU you're using. Let's do, okay, like this. Something fun. Okay. You can do top -b. Let's do the first line. Okay, and we'll see what B stands for. And then the part where it says CPU. What? Oh, I just ran out of light. Well, that's not good. Let me just use my phone. In the meantime, give me a second. That's not good. My light just turned off. Very good. Hopefully this works. Let's see. Give me a second. Aha. There you go. That should work. Hopefully. Doesn't fall. There you go. Am I visible? Yep. Cool. And that's it. Okay. Cool. So let's see what happens. Ooh. What happened? Like what's the premise of this? Like it's not magic. Let's see what it does. Echo, we know echo. Echo is like print. Okay, this is how much CPU you're using. Top. Remember the top command? Let's just look at it. This is top. Okay? So it means we wanted to take from top the first part of it and then give me just the CPU's line, which is all of this. And we can see it. Let's just take a look at it. See, this is how much CPU you're using. Ooh, cool. This means that you can use any command that exists in Linux, make or just write a script and run commands. So you can stack commands with commands with commands, and you'd have a great automation script. Okay, and you can do whatever you want. Again, I can give you an example. So if I go to my install py docker minecraft.sh, let's take a look at that. Wait a second. Sudo, wait a second, why? chmod, okay, install, actually ls-l, let's just take a look. See, we removed the reading file, reading permissions, and you just saw we cannot read what it's inside. So again, chmod plus r, which stands for reading, install, let's just do vim. Ooh, there we go, we can read it. Okay, see, that's how it works. Okay, it's not that it tells you permission denied and you can't do anything. It's just a blank space, permission denied. Okay, so you can see here commands. Okay, this is a command, this is another command. Okay, see, so in the end, this whole thing, ooh, look at this, this is what it's doing. Okay, I won't explain in detail, but this is how an automation script is using. Okay, I took this from GitHub, by the way, but yeah, like here's if statement here. I don't know if we have like loops. No, we don't. See this, it's not GD. Okay, it's if this thing has the same type as this. Okay, I don't know what this is doing, honestly. but it just works. But yeah, ooh, dev null. Okay, I'll explain what dev null is. Okay, cool. Now, this is how usually a good incomplete shell script looks like. It's just stacking commands, this one, and then this one, before that, this one. See, like I'll stop the Minecraft server, remove the Minecraft server if I have existing Minecraft servers. See, Docker pull the server, which I'm using Minecraft 20.1. So, you know, that's in the end, it's just step by step of things that you want to do. Okay, that's what shell script should be. If you start to make more complicated stuff, use another programming language, which is easier and more friendly. Okay, cool. Now. What is /dev/null? What's this? Imagine dev null as a black hole. Anything could get in, nothing gets out. Echo. Hello. I'm new here. Cool. And then we will just send this, okay, to dev null. So whenever you are piping, it means using this thing over here. The difference between this and this is that piping is from a command to another one, okay? Dev null is a file, okay? So if we want to add it to the file, we use the caret, okay? Cool so far? Again, let's do that again. Piping is only for output of a command into an input to the other one. Caret is output of a command to a file. Okay, this actually is concatenation, I guess. And this was, I think this one was overriding everything. I'm not sure of that, but yeah, careful with that, okay? Again, commands only, command file. Okay, cool. Let's send hello, I'm new here to dev null. 3, 2, 1, and it's a black hole. It means sometimes when you run commands and you get a lot of logs, okay? Lots and lots and lots of logs. You kind of don't want to see that. You run the command, anything that the command outputs to dev null. Dev null just makes sure that get erased, okay? It makes sense. It's a black hole. Everything gets in, nothing gets out, okay? As simple as that. Dev null is used to simplify a little bit your logs, okay? It means, again, I don't want to run commands that take time, but if I do ls and then I send this into /dev/null, we see nothing because anything that ls outputted goes to dev null, okay? It's just to keep your terminal a little bit more clean or tidy, okay? It's just for that. It's like your paper bin. It's like your trash bin, okay? It's just like that. But whenever everything that you send there, you cannot retrieve it, okay? Like nothing is retrievable, so be careful with that. But it's just for outputs, so no worries. Cool. Now, this was a lot, okay? A lot. Now, I kind of wanna, let's see, something interesting from Linux, and I think I'll finish with this, is, cool. What about ping? Do I have ping? Cool, okay. So ping is used for seeing or checking if out there in any IP address is reachable. Ping google.com. Oh, see that? Okay. It means it's taking 9.8 milliseconds, 12 milliseconds, well, 12.8 milliseconds, 12.9 milliseconds to reach out to google.com, which is Google server in US, okay? What does this mean? Let's break this down, okay? It means Time to live is how many jumps it took before it got destroyed. Okay, so each packet, I'm sending like a request packet from here all the way up to Google, and it jumps. For each jump that it takes, one is subtracted. Okay, that happens, and they did that so that we don't have packets flying around that never go into destination. It happens sometimes. That's why we have TTL, which is time to live. Okay, cool. Now, time is the time that it took to get from here, which is Mexico, to google.com, 9.8 milliseconds. It's amazing. Like, it's amazing. In 9.8 milliseconds, it traveled that speed. Okay, cool. 64 bytes were sent. Okay, from here, which is, I guess it's my network, all the way up to google.com. Okay, what is this? This looks weird. What does this mean? This is an IP address. There are two types of IP addresses. There are IPv6 and IPv4. IPv4 is the oldest one. IPv6 is the newest one. What are they? Like, what do they do? And here you can see it says google.com pin statistics. 16 packets transmitted, 16 got received. We didn't lose any packet, and the time total it took was 1 second. Was it? No, it's 15 seconds. So in the end, that's what it took. Everything. Okay. Again, which is, it's incredible. Like, in 15 seconds, we sent 16 packets of 64 bytes, each one, to google.com. Okay, which is in the US. Okay, cool. So if I do IP adder show, we have a lot of things. Okay, the one that we want to look for is this one. Okay, let's say we don't know where it is. Remember how we did it? IP adder show. We type it into what? Grep. Okay, we want to grep. We want to grab anything that has, or everything that has inet in it. Everything that has an inet. We are interested in this one. Okay, this is the IP address for my Raspberry Pi. Okay, this is IPv4. It means it only has 8. I think it's 30. Yeah, 32 bytes. Each one containing 8 bytes. Okay, so why 8 bytes? So 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128 times 2, 256. So 8 bytes for every single one of the slots. It means 32 bytes in total. Okay, cool. What does this mean? It means, or actually, let's start with what is an IP address. An IP address is like the name of your computer for the outside world. Okay, so based on where you are at, you'll get an IP address. If you do it in your computer, IP adder show, we can do it in my Windows computer, which should be ipconfig. You can see, I'm sorry, it's in Spanish, but you can see here IPv4. This is my IPv4. Can you see how similar my IP address is from this one to this one? It starts with the same numbers, right? 192.168.100. 192.168.100. Interestingly enough, we have /24 here. What does that mean? It means 24 bytes cannot be moved. Okay, 24 bytes are static. The first 24. It means these 8, and these 8 will not be movable. Okay, it means everything that's in my network, in my house, my phone, my iPad, this computer, my Raspberry, will start with 192.168.100. Each and every single one of them. After that, they'll have their own number. Raspberry is 13. My computer is 100. If I look into my iPad, it's probably like 5. My phone would be like 200. Okay, so you can get numbers from 0 to 255. Okay, counting 0, there you have 8 bytes, 256. You don't use or you don't do anything from this, okay? Like your router does it for you, but zeros and 255s are never used because those are broadcast channels. It means if you add a 0 to something, it's connected to everything at the same time. Okay, so the network manager has a 0 or a 255 in it, and it sends messages or broadcasts through those channels. Okay, in this case, we have a 13. Okay, you can see here it says INET 6. What does that stand for? Why do we have 2 IP addresses? Well, for 32 bytes, we have, I'm not sure how many combinations, but it's 2 to the power of 8, I think, combinations. No, it was more, 2 to the power of something. Okay, so it's a lot of combinations. We are running out of them. Okay, so that's sad. People came up with a solution. Having IP addresses instead of normal bytes, it's in hexadecimal. It means 8 bytes until we get to 128 bytes. Okay, so 8, 16 up until 128. Okay, if you see, I think it's not here. Okay, no. In this case, we don't. Oh, here it is. Okay, cool. If you see these 2 dots, this is an IPv6. This here, it means zeros. Okay, so we have to have 8 of these thingies. Okay, so 1, 2, 3, 4, 5. We're missing 3. It means from FE80 to AC22, we have 3 chunks of zeros. So it's more readable. So for you to read it easily, they have this concatenation of zeros. Okay, this means we have X amount of zeros or packets of zeros. So you have to count how many of them we need. In this case, we need 3. Okay, and the 64 is here. It means 64 first bytes will not be touched. Okay, and if you see FE80, see that? It means it'll start with the same, here it is, FE80. See that? It starts with the same type, with the same bytes, yeah? Because it's an IP address. If you try to connect, if you type this into your computer and you do as I did, what I did was, actually I have it here, SSH, which is a secure shell, which is a way of connecting my Raspberry to my computer, Bully, which is my username, at 192.168.113. You can see it's my IP address. Yep. If you type this, sadly enough, you won't be able to connect to my Raspberry. Okay. Why is that? Because this is not a global IP address. It's a local IP address. It means the house that's in front of me with their own network, they have their own 192.168.100. Every single house has that protocol. Okay, it means every single house has this. If you try to connect to this number, it'll connect probably with your brother's cell phone or your iPad or whatever. Okay, and if nothing is connected to 13, nothing is named 13, then you won't be able to connect to anything. Okay, so for that, and I kind of want to bring this up. Where was the comment? Where was the droplet comment? Here it is. What is a droplet? So if you try to connect into a droplet or a server on cloud, they give you an IP address that's global. It means from Puebla, Mexico, from the United States, from India, from China, from wherever you are connected to the network, you can access it with the same number. Okay, that's the difference. This one is local. You have to be in my network to connect to this. If not, it won't work. With global IP addresses, the IP stands the same wherever you are. Makes sense? I hope it makes sense. It's a little bit of too much info, but yeah, that's how it works. So 5 minutes to go. I'll be sending you all, just in case. Here it is. Cool. Now for you to check in and like and comment. Cool. Now I think that'll be it. I think I covered most of what I wanted to cover. In the end, okay. In the end, if you have Linux and if you have a terminal like this, don't feel afraid. Don't feel bad if you don't know what to do. You have the basis now. You know how to manage. Okay. If anything, go to the internet and ask chat GPT or whatever. Hey, is there a command to I don't know, something? I'm pretty sure there is. Okay. It says, yeah, it kind of makes sense. Lots of info, but the stream was probably one of my favorites so far. Cool. Thank you. Happy to hear that. As a Linux noob, hey, no one is a Linux noob. Like, you just have to practice a lot. Okay. When I started with Linux, that's how it was. It was intimidating. In the end, you know, you just get a hang of it. And if you want to dive more into Linux, I recommend you the MLH Production Engineering Fellowship. It's a 12-week fellowship in summer where fellows work alongside Meta, okay, to maintain servers alive. Okay, it's a lot of Linux, but it's really cool. Okay, so yeah, great stream. Thank you all for joining. Then don't forget to click on the link and yeah, you can just go check in. But yeah, where's the application for PE? I thought it was on the SWE and SRE. Nope. Oh yeah, it's SRE, by the way. Yeah, it was called PE, which is production engineering, but SRE stands for site reliability engineering. It's kind of the same thing. But yeah, it's SRE. So go into SRE. I don't know if applications are open for summer. If they are not open now in March, they'll probably be open in April. But yeah, cool. Apply, and I'm a pod leader there, so I'll be happy to have you there. Cool. Nice. Then good luck with your application. I hope that everything goes well. And yeah, then thank you all for joining. Just put my face here. We'll be seeing you in my next stream, which is in 2 days. It's about Arduino, so I'll be happy to have you there. And yep, I think we don't have any more streams. Let me double check pretty quick. Oh yeah. We have. Oh, it's tomorrow. So tomorrow at 5 a.m. ET, we have Gartic Phone mini event with Aziman. So yeah, just join 5 a.m. ET if you are awake. And yeah, thank you for joining and see you. Bye-bye. Thank you.